Hello everyone. Today we are back with another episode where I will be interviewing my brother, my cousin brother, Rohan Mondal. He is now just introduce yourself.
In final year at Iiser, Kolkata, currently pursuing physics and basically master thesis.
Okay, so this will be a physics podcast, and I have set up a very mature setting. We are in the balcony, and we will continue with the questions. Hope you like it. Okay, first question I'll be asking is about the different papers and the subjects. So, yeah, tell us about it.
So at Iiser, Kolkata, we had learned variety of subjects starting from classical mechanics, which goes beyond what you know at the school level, which is Newtonian mechanics. It goes into Lagrangian, Hamiltonian dynamics, and it's basically it's not very different from Newtonian mechanics, but it's just a very fancy and very powerful way of doing this. Simplifies problems a lot. And then you have quantum mechanics. We had basically three courses on quantum mechanics. Yeah. So quantum mechanics is very much stressed upon. Obviously. Then the other courses like electromagnetism, so statistical physics, okay. And also some of we also had some laboratory courses like condensed matter laboratory, electronics laboratory, optics laboratory, and some of the advanced courses like say I had done nonlinear dynamics, okay, which is basically classical mechanics, and then uh, GR, which is general relativity, and quantum field theory. That's a course I did. That was one of the hardest courses I've ever taken.
Okay, cool then. So, pretty much like a very wide outlook we have got. Now, I'll be asking about the respective scopes and prospects of every field that you have. Tell us about the precision wise, priority wise, the most prospective,
Yeah.
and then going to the least prospective. Yeah.
Okay. So starting with the in the as you said, I'll be saying in the order which I this personally only my absolutely don't think that it's absolute. This is how it is. Is my opinion. But seeing at the things at my institute, I've seen that condensed matter physics, okay, is the most like has the most amount. At least I can say that half of our faculty is of condensed matter physics. Okay. So I would say a little bit on this condensed matter. So condensed matter physics is basically quantum mechanics. Quantum mechanics when you apply it to crystals, to the world of solids and especially crystals. Okay. So then what happens is that the field is very diverse. There are a lot of things to study, a lot of exotic phenomena, and it's very interdisciplinary in nature also. It can be applied in the technology. It can be also in polymers and biochemistry. It goes extend its reach beyond. There are just so many places. So that's why perhaps it's so much popular, and because of it has so many interesting phenomena which you discover every day, like things like you hear of things like time crystals and stuff like that. It's really actually look at it, it's really interesting field. So I would suggest all of the people who are the undergraduates, who are watching. So consider your interest, and if this field has it's really promising, I would say, condensed matter physics. So some of the research topics I would say like the quantum materials, like say 2D materials like graphene. They have show very unique properties, and then you have topological insulators, okay. And then you also have quantum magnetism. So some of these properties like some of the materials uh, display magnetism, and using condensed matter physics you can develop such unique materials which use quantum phenomena to uh, basically even your ferromagnets, even those are also not completely understood. So that is also like
Yeah.
you can say quantum magnets. So, and now condensed matter physics, say about the industrial aspects, obviously it's everywhere. So say the lights you use, the LED bulbs you use, everything, it's all condensed matter physics. So starting from the transistor in your laptop you're watching right now, or basically any device, or even say many sensors, optical sensors and optical devices, it also comes from condensed matter physics. And then many of the, as I told you, yeah, soft materials like liquid crystal display. So and basically liquids. Even in liquids also there are in soft materials like polymers and stuff. There are also condensed matter applies. So this is one of a great field. I would really suggest you to look up it because it has a lot of scope of research in abroad here also. Next, I would okay. The next field I would say is um, quantum information. Yeah, quantum information science. Okay, so basically, quantum information is it's a branch of science which deals with properties like entanglement. It is a level to study quantum mechanics. You'll see that it comes. You just study it. It's not that difficult to understand what exactly it is, but its application is immense. I mean, if you try to develop tech, it's like can't imagine how amazing and how wonderful things can. So the effects of like tell you quantum tunneling and basically the non-local nature of quantum mechanics. So using this, there basically yeah, the quantum computers which you see qubits and so currently a lot of active research both in academia and industry is going to develop efficient quantum computing algorithms and so quantum cryptography basically which is carrying process of you know so it's quantum mechanics actually allows you to transport information in a very secure manner. The
Yeah.
process of quantum tunneling you can look up upon these things. Yeah. And yeah, there's one thing which is which really needs to, this field of quantum information science is aiming to uh, mitigate. Is, see, in the quantum world, the quantum phenomena which occur, it only like there's a thing called coherence. It only stays up to a certain very tiny distance. After that, there's a lot of noise comes in. So noise and so that's why you see the quantum computers are super cool. They kept very near zero temperatures. So a lot of research is being done. So how long can we bear this? Look, there are algorithms being developed so that you can correct for this noise and errors. So that for practical distances we can use the effects of quantum computing and quantum transportation of data. Now next, okay, that says about it. Next, I would talk about yeah, the field is atomic and optical physics. Okay, that's another very important. So this field basically deals with the interaction of light with matter. So mainly the quantum properties of light study. So basically the laser physics, all the physics of lasers. Okay, that's one thing. And then recently you must have heard about the Nobel Prize, which was because of something about attosecond spectroscopy. So that's basically imaging the chemical reactions in a molecule, how fast they occur. Yeah. You're trying to basically image that.
Yeah.
Yeah.
Because that's crazy.
That's crazy, right?
Yeah.
You're trying to image
Imaging
the
the
chemical
reaction.
reactions. Yeah, the atom splitting. So that at that much speed. Okay. An attosecond is like 10 power minus 12, I guess. Yeah, that's or even more.
That's pretty cool.
Yeah, okay, that's pretty cool. It's much more than that. I forget about it. Yeah, but you can imagine it's just unimaginable. Okay, so you can do this. Yeah, so research is going on to study the ultra fast dynamics of these molecules and
Yeah.
yeah. Also a lot of precision measurements and things. See, everywhere in physics there is a lab. There will be a lab. In lab you will have there will be some of the other optical equipment. Say I'll talk about fields like astronomy, which also I'll talk about it soon. You definitely need to have a lot of these optical components in it. And
Absolutely.
so there's a lot of scope. You talk about it in say industrial point of view, uh, both academical point of view to develop precision measurement techniques. Yeah. And yeah, so that just says about it. This field. So there's a lot of scope in this field. Now I would go to the next field. Okay, yeah, and then actually, yeah, there are some emerging fields also which are nowadays appearing. Say, I would say like um, one of them is like quantum thermodynamics. So one of my friends actually has been doing a project in like developing quantum batteries. Okay, that's like uh, extracting work from a quantum system, and it's like uh, bringing thermodynamics in the realm of quantum mechanics. Okay, in the things like open quantum, you will hear open quantum systems stuff. Okay. So measurement of entropy of a system. Okay. So the how much information you can extract from a system, all these things. So it's related to somehow to quantum information, but yeah, these are it's a new. And then quantum, there are a lot of interdisciplinary works also. Uh, so in biophysics also you have a lot of these applications in DNA molecules and all that. People are trying to get a more and more accurate, better picture of it. That does it. And then yeah, nuclear physics. Yeah, nuclear physics also is a branch which uses
Like we were talking about it last nuclear physics. I would, because I am from geology background, I would definitely ask you about the field of geophysics. How much you are aware about geophysics?
physics. Yeah, actually, yeah, I have friends in my Iiser PhD department. So they use various techniques, say in arts, in your seismology, and there is like they have talked to me about some inverse theory and stuff, Fourier
Yeah.
analysis to they see what the internal structure of Earth like, and depending on how kind of uh, locating the say some seismic event occur, and you're trying to triangulate it from various places, from say point A, point B, and point C.
Yeah.
So doing that allows you to actually get to gauge the internal structure, like what exactly lies within.
Yeah.
So yeah, I think it's pretty interesting. Sense, yeah, you can use this wave mechanics and the knowledge of wave mechanics and pre-analysis to actually understand what lies within. Uh, it's actually a great scope for those who want to work in art science and as well as do some physics. Yeah, usually you get a lot of funding for doing this kind of things which are more interdisciplinary. I've seen.
Yeah, that's it's always better to find, mix and match the subjects and you get something new, and that's where the funding lies.
Yeah.
Yeah, that's how the research works. Okay, we will talk about research now. I'll be asking you about the industrial research as such and the academic.
So few more things.
Okay, few more fields. Okay, they are still left. Okay.
Yeah.
Yeah.
So that's more or less the I told mainly the very popular search is going on. So in the quantum domain, and then there are some more search I would say in classical domain also. Like I told you about nonlinear dynamics, I took up that. Yeah, actually I had done a summer project on that also. So, uh, in that I had to study the bifurcation characteristics of a specific system. Basically, nonlinear dynamics is another great example where computers are greatly utilized. Okay? So there will be a point, you know, I don't know, depending on your exposure to physics, you cannot solve everything. Alright. No matter how intelligent you are or anything, there are problems which you cannot get exact solutions of. So at some time you will need to deal with computers and stuff. So no matter how hardcore theoretical you work, there will be you have at a point you won't be able to solve a different basic differential equation. I would say because it's too complicated. It has too many variables. Okay, so nonlinear dynamics actually works with such complex systems. Okay. So say
Yeah.
weather, climate. Say
Very.
your heart, function of your heart, like and stock market, finance,
True.
yeah. Even ecology, like population dynamics. So there are competitors, say prey and competitors behave. So you want to predict what will be the outcome, whether the prey will go extinct or the predator will go extinct. So you can do all this using nonlinear dynamics. So basically, what you do is you kind of model the system in a would say empirical way. I mean, you can do it in a semi-empirical or whatever um, or some analytical way, but you have to determine a model which kind of predicts the behavior, like the rate of change of population, say in a particular species. So it depends on the factors like how much food is available, okay, and what is the what is the maximum carrying capacity. Okay, so all those things you build a basic mathematical model, and then you solve the equations numerically. Usually, the outcomes of those equations are very complex, and many often many they will exhibit chaotic behavior.
Yeah.
So, yeah. So very slight perturbation in initial conditions, there will be a drastic change in the outcomes, and so it's very important to study them. So
I think nonlinear dynamics is something that we will talk about in some other podcast about it, because I find it really a fascinating,
yeah,
and
yeah, absolutely.
that's it's prolific. It's going to solve a lot of issues and various fields we can see, and it's very practical. It's pragmatic. Okay. So can we move to the next
Yeah.
question? Like
Next,
now,
okay.
yeah.
I'll just cover
Okay, two
fields.
more fields.
Yeah.
Okay, yeah,
So
sure.
non-linear dynamics was one field. Yeah. And then yeah, the main field I want to talk about is astrophysics.
Yeah,
Yeah.
sure.
So
Astrophysics,
many of you at this stage you must be very fascinated about okay
astrophysics,
stars,
stars, space,
okay space. I just want to do astrophysics. When someone asks you, I'll go, I'll become
an
will go to space.
astronaut.
I'll be astronaut. This fascination is there in all of us. So yeah, a few things I would like to say is that see, the main thing is in astrophysics, if you want to become a good astrophysics, we have to be a good coder. You see, you need to know
Ah,
a lot of coding. So from now, if you want to go into astrophysics, you better get
get
learn
your
coding.
touch into coding.
Yeah,
C, C++, Java,
I would say
Python.
Python.
Python is
Python
the
will do.
basic. Python will do.
Yeah,
Python, and then also AI,
yeah,
ML and
absolutely,
DL.
absolutely. ML has a lot of
ML has a lot of applications, machine learning, deep learning, everything about it.
so
Yeah.
so the opportunities are huge. I would say in be it more than India and abroad, if you want to get a PhD, bring it. So the easiest way to get a PhD outside is to do something in astrophysics. I would say. So the scope and funding is like huge. Yeah. So there are like so many things starting from heliophysics, the studying sun, to then studying the exoplanets. Okay. Okay. And studying okay. Recently there have been gravitational waves. Okay. Studying like faraway objects like black holes and neutron stars and everything. Gravitational wave information. Then studying even cosmological stuff like the 21 centimeter signal which comes from the beginning of the universe, CMB. Okay. It's like it reaches everywhere. It's like so many. It's like so many. I cannot even call. I cannot remember so many. So there's so much to explore. But yeah, I would say one thing that yeah, you have to be little custom with coding, and you have to know that there will be a lot of data analysis and handling data. So you better understand that. So there is some fascination at this point you must be having right now that yeah, it's going to be awesome. I'm going to dealing with stars and everything. That
Yeah.
sure that that's going to be there, but you better watch out that it's going to have a lot of data analysis and coding, and yeah, you have to and soon enough you will have to start using AI and machine learning also. That also is going to help you a lot. So, and yeah, there are industrial opportunity if you want to get job also that is there. All the space tech companies, Tesla.
Obviously, that comes to the top of the mind of whenever we talk about astrophysics. Yeah, the last point I would say, but is it left and something is left?
Um, is there? Yeah, and yeah, just one.
Yeah.
Yeah. So that does it for these fields. Yeah. Then the fields I would speak about is the yeah then the theoretical physics. So many of you would actually go into the pure core theoretical physics. So some of the fields are like particle and high energy physics, okay, or say gravitational physics, say GR Einstein. You want to do research in gravity, so you want to like there are many research trying to modify Einstein's gravity uh, because it fails at black holes, and at small scale. So quantum gravity, uh, string theory. Okay. Yeah. So these fields, yeah. One thing I would like to say is if you really want to work in this field, if you really want to go into this field, because I'm really being serious at this point, because you really need to have an extreme amount of dedication. It's it's nothing short of becoming a monk, absolutely. And then the level of mathematics required is also like it's a lot. Okay, so you if there were option you have it's depending on your institute which you will join. There will be options to take some math courses electives. So you have there a lot of maths will be required. At least say like for GR, I would say some knowledge of differential geometry is essential, and some knowledge of group theory for particle physics, energy, and yeah. So basically that's about it. And topology, yeah, that's also a very important. Uh, some basic idea of topology also you must have. Working with string theory and okay. So that's what I would like to say. But if you talk about opportunities, yeah, I am a little bit yeah,
Skeptical.
so skeptical about it. Yeah. Truly speaking, the theoretical physics, especially particle physics, is pretty saturated. You see, the standard model has been a sacred model till now, and so many experiments have been trying. CERN is trying to do to find something new, but nothing so far has been found. All experiments seems to be satisfying the standard model, and so far uh, at this stage, there's nothing you are not able to get any breakthrough discovery as of yet. But yeah, don't be hopeless as of yet.
Yeah.
Yeah, if you're really interested in it, you better get on it right now. Get on, do the math. Remember, always do the math. When you're going into theoretical physics, you have to be
Maths.
friends with math. So this pure math stuff, which I told you about. And yeah, but yeah, you're going to enjoy it, sure. Might have less opportunities. It might be difficult to get PhD outside also, uh, and you need to have good grades. But yeah, I would say it's a, if you enjoy it, it's fine as long
That's
as
great. Great, yeah. That was huge and that was really, insightful and a lot of, because it's a very important question to see the scopes about every field and yeah, it was great information from you. Thank you for that. We'll go to the next question. The next question is about the industrial research and the academic research. What are the differences and what subjects are there for the industrial research and what subjects are there for the academic research? Is there any differentiation like that?
see, industrial research and academic research, I would say, yeah, differences. Um, yeah, it's industry where it's like more oriented towards products and what you have to manufacture, and it's more oriented towards see, academic research is free. It's like you're free to research anything. You suddenly got something like a bizarre thing like time crystal. You go and discover it. Okay, let's go. Let's discover it. Let's get a paper on it,
Mm.
published on it. Okay. So you're free to do anything you want.
Anything.
But when you go to industry, it's heavily dependent on what your uh, your company wants.
Yeah.
What is the pressing need? Say you want to launch a PSLV rocket or some new
Yeah.
rocket, and that will you desperately need some kind of new kind of fuel. Okay, okay, some new liquid fuel. Okay. So you have to work on that. So now, sorry, okay, I have something on solid fuels or something.
Mm.
You have to know. But what at that point of time, what's required, you have to like go more into that. Okay. So that's a thing. And yeah, other than that, yeah, see, at many times it goes hand in hand. See, recent it's a Microsoft discovered a chip called Majorana one that uses a lot of concept, a lot of research in condensed matter again, which I told at the beginning, condensed matter physics, topological insulators and stuff. Yeah. So in that sense, it's more or less the same. But academic research is just like more free.
Mm.
Yeah. You can do what you want, but industrial research is like more product oriented, more like more towards you.
I would ask you like, is there more scope for when a guy or when a person is doing industrial research, then the person has the opportunity to join academia and also industry. After his PhD, he can join industry if it's an industrial research. But if it is totally an academic research, then nothing is left other than the academia, right? For his career, that I'm saying. Then nothing else. Like either if it's absolutely like an academic research, you will end up with the postdoc loop that we famously known about, the infinite loop of postdoc. And if you are getting placed in that, you will be in the academic field as a professor, as an assistant professor. That's the
Yeah, that's true. That's true. Because see, most
yeah.
people who go into academia and do PhD and then yeah, as go into a postdoc and then yeah, you become an assistant professor where you do research in that field in your institute you join. Yeah,
Hmm.
but that's true. Like if you go into this path, it usually that's the case because our most of our professors who
Hmm.
teach us, all of them have done some PhD in some of them have done in ISC Bangalore and India, and some of them have gone outside to somewhere Stony Brook University or something. So where Max Planck or what was where. So
Yeah,
yeah, so that's the thing. And then they've been as a postdoc at a certain amount of time, and then
hmm.
they're
They were
teaching.
placed.
They were placed here. Yeah. So
Exactly.
that's true. That loop is there. So if you
Hmm.
come into this academia, so you will be yeah. Then the professors talk about the H index and stuff. Like
Yeah,
it's basically like
the research
the
index.
citations per like it's like an index which shows like how much impact you're making, how much impact your research papers are
Yeah.
making. Yeah. In the academic world, this is how it becomes. Like when you become a professor, then you guide some more students. Like you have your own PhD students that time. Yeah. Then you publish papers with them, and then yeah, that's how the stuff works in academia. Your H index and these parameters. Yeah, how much impact you are making. Yeah.
Yeah.
And then if your research is very impactful, then you might get some award or something. Like
Yeah,
yes.
sure, absolutely.
Mm.
So I'll be coming to other awards,
Mm.
but before that, I'll ask you about the scholarships. All the scholarships that can one can get from starting from the BSc. till the highest level that possible, like you can remember or you can quote. So all the scholarships.
Okay. Scholarships, so see, before getting into BSc, like say a plus two, plus 12 student were trying to get it. So yeah, there's well, in our times there used to be a great scholarship called KVP.
Yeah,
That's gone.
KVBY is gone.
It's gone.
That's sad, really.
That's really sad. I don't know. You guys might even knowing about KVP now, but
Yeah.
yeah, we had this exam in our times. It's a great scholarship exam. And then now there's only DST Inspire. There's
I
this,
think JBNSTS is also there.
yeah, regional scholarships. Yeah,
Regional
like in
scale.
see, West Bengal, you have
West
JBNSTs. And yeah, Inspire is the only one that I know.
Yeah.
Yeah. And then each state has its own some kind of, they might have some scholarship scheme. Yeah. And yeah, coming to this, yeah, when you're at BSc, yeah, then scholarships while doing BSc, yeah, that's not exactly that much I heard about. But yeah, but if you want to go to now, if you're talking about going to master thesis, do master thesis somewhere. So many of our friends, like this is particularly I'm doing a BSMS program. So some of my friends have chosen to exit it for fourth year and go to master thesis somewhere else. Yeah. And yeah, uh, for that there were in like in US I've had some Fulbright scholarships.
Fulbright scholarship.
And in UK there is Rhodes scholarship. Okay. And DART,
Yeah, that's quite famous.
yeah, in Germany. Okay. And other than that, actually, I would like to talk about internships. Actually, you want to get some kind of like scholarship kind of thing. Okay. So go for internships. Everyone actually in this academia field, especially in these institutes like ISC, Iisers, and Iiser, and all this, where you study BSMS and the very important thing is to do with an internship is a very important thing. I will talk about it later. So yeah. So, why you need to do an internship? I would say about it. So, internship actually is basically 2 or 3 months to go to some institute, get a guide over there. Okay. So, it starts from second. Now, the second year level itself, you can do internships. Okay. So, it gives you some research exposure. Basically.
Sure.
You are given to study a paper.
Yeah.
So, at the beginning, you are just given some papers. You have to reproduce the results from the paper. Basically, and if you are doing well, then maybe some new problem will be posed to you where if you can put some of your inputs to it and maybe something you can do in it. So it's more of an experience and then real work. It's more of an experience you get, research experience. So doing that, it's very important because see, applying for PhDs or master thesis requires a lot of recommendations. So where will you get these recommendations? So it's like from these internships, the guides you get. Okay, so the work which you do in an internship doesn't end there. You can even continue that work. Say you do an internship at third year somewhere. Then you can, if you have good relations with the guide, and you can continue the work and you can get it published in the form of paper, maybe in the fifth year. Okay. So it's a great advantage. I would say it's great. It's like a hierarchy. It's like you do an internship with the second year. Okay, then that helps you in that boosts your CV. Okay, next year, third year, you're able to get somewhere even better. Okay, in that way, can like climb up the ranks. You can maybe get an
international exposure as well.
exposure. Yeah. So that yeah, I would say an experience of my like there's this program called NIUS. Okay, I'm just telling you. National Initiative on Undergraduate Science. Okay, this NIUS program. This is just check out. It's in second. You can apply for it for second year, starting of second year. So it's organized by Homeopa National Institute. Okay. Okay. So what they do is they do initially some camps. Okay, training camps. Okay, at the second year. So you are given an exposure in all subjects. Research, contemporary research in all subjects. So various professors they tell you about the current research and everything. Some of their topics of research. Okay.
Yeah, sure.
So you attend these camps. Okay, and then at the end of at the end of the second year, you are given to write an exam. Based on what you have learned, and after qualify that based on your performance, you get assigned to a guide. Okay. So then actually it's basically a long-term internship. I will say it's like from your third year, fourth year for 2 years you are associated with them, and you do. There's a high chance you do some good meaningful research. Okay, and I would say very of my close friends have been done this. Okay, second year, and even I also actually had the opportunity of applying, but at that time I didn't apply. I still regret it because yeah. because that really, yeah, it really makes it's like a staircase for them. Okay,
Mm.
they did that in second year. I thought, okay, they're doing some camps and everything, but then they got into a touch with some great eminent physicists in India, all among India, okay, and some in TIFR, okay, somewhere in Ayuka, and various in such institutes, and working on that, they did got some great work. They did some really great work in that, okay, because it's a long term internship. You see, long term internship, great chance that you do some meaningful work in. You can get your paper published also. There's a great chance by the end of fourth year. And so doing that really propels your chance at when you're trying to apply for master thesis or some other international internship.
It's always better that you
Yeah.
go for internships, be it like industry, academia, wherever the institute. Go for internships. Then they will be giving you the scholarships. They will be giving you the LORs, and that will take you ahead in your career. Okay. I think.
Okay, I'll mention one.
Yeah. Sure.
In India, there's this Indian Academy of Sciences, so definitely look out for it. You can do it in the second year, third year level. Second year level is when you can apply. So
Nasi IAS.
yeah, Nasi, yeah. So that's a great opportunity. You get stipend also, and then there are many of like ICTS also has their own JNCSR, and many of the institutes. Okay,
I think I will name INSA. INSA scholarship, that's the
yeah,
thing, and RCISC is the INSA scholarship. There is SN Bose
yeah,
scholarship.
SN Bose scholarship. Yeah,
SN
that's
Bose scholarship is also a very good one. I don't remember anything. Other than that, if you are going in PhD, Shama Prasad Mukherjee scholarship, Pradhan Mantri
yeah,
research fellowship,
okay. Yeah. Now,
PMRF,
if you're
all of
going to
these things.
PhD, I would say, yeah.
Yeah,
So there's this PMRF, so that gives you a good, I guess,
PMRF is good.
80,000 per month or something.
Yeah, absolutely.
That's a great
That's
amount.
huge.
Yeah. So look out for it, PMRF, and then there are exams like CSI and NET, and NET. So from that also,
Yeah,
to qualify, you'll
you get qualified from the CSI and at top five, you get
JRF.
the Shama Prasad Mukherjee scholarship,
Yeah,
which is
that's
like
right.
50,000 approximate,
Mm.
and only one scholarship at a time. That is the rule of
Yeah,
the
that's usually
scholarships.
the rule. Yeah.
So that
You cannot be taking from here to there.
everywhere.
You can't do that. Okay, don't think of
Okay,
it. You'll be
only
caught.
one scholarship at a time.
Yeah.
So that just get the highest one, and that will do. Okay, this video is taking us long. I think we will like uh, make it a part. This will be the part one, and the part two will be coming up. We will come in the part two. There will be we'll talk about awards, the degrees, the higher education abroad. How is it like India versus abroad, and also about the different institutes, IITs, Isers, NITs, TIFR, and every institute. We'll talk about them. We will even talk about some of the eminent professors of India whom we should like look for. So that is for the part two. See ya.